Okay, so for page 38, we're going to do a few more examples. So just label this more examples. A few things that we need to note whenever we are using synthetic division. So the first one is that when you're performing synthetic division, if you have a remainder of 0, you can use the values in the last line to start the process over again. And so I have an example to show that. We're going to divide f of x by x plus 2 and x minus 1. So we know two factors, and so we want to know what our result will be when we divide by these two factors. So first, we'll start with x plus 2. And so negative 2 is what's going to make that 0. And so I'll take the coefficients 2, 1, negative 5, and 2, and then we'll start the process. So you may want to go ahead and pause it now, because when I reveal this, all the answers are going to be there already. So just try it on your own first and then see that you get the same result as me. So the first thing we're going to do is bring that 2 down. And then I'm going to multiply the negative 2 by 2, which is negative 4. I'm going to put that underneath the next coefficient. Then I'm going to add 1 plus negative 4 is negative 3, and I'll start the process all over again. Negative 2 times negative 3 is 6. I'll put that under the next coefficient, negative 5. I'll add that to 6, and then I'll get positive 1. I'll do it again. Negative 2 times 1 is negative 2, and then I'll add it and I get 0. So now we know that we have x plus 2 goes in there evenly. It is a factor because we get the number 0 here. And these are going to be your coefficients of your quotient. Since you would have had to divide 2x cubed, the polynomial, all of this, by x plus 2, the very first one would have been an x squared. When you multiplied x to get into x cubed, you would have gotten an x squared. So we're going to reduce the power by 1. And these are going to be the coefficients of my quotient. So we have 2x squared minus 3x plus 1. And so what I mean by starting all over again, it wants us to divide by x minus 1. Well, this is a factor so far of f of x as well. It's x plus 2 and 2x squared minus 3x plus 1. So those are both going to be factors. So it looks like this so far. We could multiply these two out and get back f of x. So what we're going to do is we're going to take this 2x squared minus 3x plus 1, and we're going to actually use synthetic division with that. So the coefficients that I already had, that I ended with, were 2, negative 3, and 1. Now, the divisor x minus 1, the thing that makes that equal to 0, is going to be 1. So I'll put that on the outside of my box. And then again, you may want to pause the video at this point to see if you get the same thing. So when I bring that down, the 2 comes down. 1 times 2 is 2. And then add negative 3 plus 2 is negative 1. And then 1 times negative 1 is negative 1. And then 1 plus negative 1 is 0. So we now know that x minus 1 goes into f of x evenly as well. And so now these are going to be the new coefficients. Because I was going into 2x squared, when I would divide that by x minus 1, I'm going to end up with reducing the power by 1 as well, which means now I'm going to have a 2x, and then this will be my constant minus 1. And so my final result then is going to be 2x minus 1 to answer the question dividing f of x by these two factors. This is going to be my answer, 2x minus 1. Now, I could rewrite f of x, which is my original polynomial, with using these three factors, x plus 2, what I divided by first, x minus 1, and then my last factor would actually end up becoming 2x minus 1. So you'll notice I've actually been able to actually factor f of x as well and write the prime factorization because I didn't start all over. From here, I continued with the last line, and then I did the process over again, which allowed me to break this down further and started going back over to the original problem and starting all over again. And so it makes this easy for us to find the prime factorization of f of x. All right, we've got a couple more examples. So our first example here, we have another note to make sure of. It says when a term is missing, you must put 0 for the coefficient. So if you have a polynomial where you are dividing and it's got any terms missing, if you don't put the number 0 in those places for those missing terms, you will get the answer wrong. So for example, we want to divide x cubed minus 27 by x minus 3. So I have two terms missing. I have the x squared term missing and the x term. So the first coefficient is 1 for the x cubed, 0 for the x squared, 0 for the x, and then negative 27 for the constant. X minus 3 is what I'm going to be dividing by. This is my divisor. So I'm going to put the thing that makes it equal to 0, 3 on the outside of a box. If you want to pause the video now at this point to see if you get the right answer, you may do so. And so with my synthetic division, I'll bring my 1 down. I'll multiply. 3 times 1 is 3. I'll add. I'll get 3. 3 times 3 is 9. I'll add and get 9. And then 3 times 9 is 27, and I'll add and I'll get 0. So when I go to divide this, these are the coefficients of my quotient, x squared plus 3x plus 9. And I used x squared because x cubed would have to be divided by x in order to get my very first term when doing long division. So I reduced my power by 1. And so now, when I'm dividing, my actual answer is x squared plus 3x plus 9. That's my answer. This is just saying that my original problem, x cubed minus 27, could have been written as the quotient times the divisor. By the way, this should look familiar. X cubed minus 27 is actually a difference of cubes. It would be x cubed minus 3 cubed. So this would be like my a cubed minus b cubed for difference of cubes. And if you look up that formula, it first says a minus b, which matches this. Then it says a squared plus ab plus b squared, which actually matches this as well. So I told you prior, whenever we started learning about difference of cubes and sum of cubes, we could use synthetic division to find what the quotient would be. And so this is what I was talking about when I said that. So in this case, we could have factored this and gotten the same answer, x squared plus 3x plus 9. And then the last example for this is an application type problem. It says find the value of k so that the remainder is 0. And so we want to divide 2x cubed plus kx squared plus 7x minus 2. We want to divide that by x minus 2. So we'll start, we don't know what k is, but we'll at least start with what we do know. So far we have the divisor x minus 2, the thing that makes that 0 is 2. The coefficients are 2, positive k, positive 7, negative 2. And so it says that we want to have a remainder of 0. This is not supposed to be here, so I apologize that this is here right now, so don't write that in yours. But it says right here that we want to have this as a 0 here. And so what we want to do is we actually want to work forwards and backwards at the same time to find k. So we'll start by working at the back first, and then we'll make our way this way until we get stuck here, and then we'll work forwards. I'm doing this, I ask myself, okay, if I want this to be a 0 here, what would I have to add to negative 2 to make that happen? Well, that answer is I would add a positive 2. So now I have negative 2 plus 2 is 0, so this works so far. Now remember, I would have had to multiply something here to get that 2, and I would have had to multiply it by this 2 right here. So 2 times what would have to have gone here to make that a 2? Well, that answer is 1, and so I'll put a 1 here. Now, you would have had to add up and down, so you ask yourself 7 plus what would have given me positive 1, and that answer is negative 6. And then we start all over again. So what would have given me a negative 6 here if I would have multiplied this sum number here by 2? Well, that answer is negative 3. And so I'm going to put negative 3 here. Now here I get a little bit stuck because I don't know what k is, and so this is where I'm going to have to go and work forwards now. So I'm going to go ahead and pause here, not literally pause, but I need to go and work forwards now. So if you remember with synthetic division, we always bring down the first number regardless of what it is, and so I would have brought down a 2 when I was working forwards. And then I'm going to say, okay, 2 times 2 would have been 4, which would have been here. And so now I have to ask myself, okay, what would I have to add to 4 to give me a negative 3? And that's what's going to be my value of k. Well, in this case, that answer is negative 7, because negative 7 plus 4 is negative 3. So I know now the answer is my, for my k, is going to be negative 7. So I would just simply write k equals negative 7, and I'm now done. So for one like this, you would do your synthetic division both forwards and backwards in order to figure out what your missing variable is going to be. And that's it for this page.